to ask this key question: can we have in an instrumental way of telling whether somebody is conscious or not? So we do TMS, repeat it, we get the voltage, we get the currents, we binarize the currents, we get the spatial-temporal matrix, brain areas, time, roughly half a second, we get a pattern of activation of currents. And then we can, after zapping the brain with TMS, we can zip, that is compress the response, and get a rough equivalent of integrated information. Very rough. That's not zip compression. But we can put a number on it. That number is not just a function of how big an activation you get, it is how complex it is, how big the repertoire of states is available in the system. You do this in lots of subjects, in lots of brain regions. When they are awake and conscious, it's always high, around 0.6. And then every subject, this is an individual subject, if they fall into deep sleep, it jumps down to 0.2, and they are everyone. Midazolam anesthesia, same thing, xeno anesthesia, propofol anesthesia, so very different anesthetics, different mechanism of action. You lose consciousness. There's PCI, perturbation complexity index, which is a rough version of 5, drops down, and then it comes back. Are we done with this? Are you trying to put pressure on me? We do that in vegetative, minimally conscious subjects who emerge from minimally conscious. They speak to you and log in subjects. And there, it also works, again at the individual subject level. So far, we haven't had a single false negative. And there's nothing like it in the literature. We basically have no way apart from behavioral tests to figure out whether somebody is conscious or not. This is based on a theory, and so far it works very well. It's not perfect, of course, and it's very rough. But it's good to see that it can be used. Now I'll finish with explanatory power and inferential power very quickly. Remember I started with why not the cerebellum. I didn't even discuss why not afferent pathways, why not the poor retina not contribute to consciousness, why not efferent pathways, why not basal ganglia, why not deep sleep, even if the brain is active, why not seizures, even if the brain is super active, super sick. Well, you can do these simple mind models in which you sort of capture the essence of those conditions in the brain. And in all these cases, based on first principles, IIT tells you it should or it should not be conscious. That's why it's not a maximum, it's not high, it's not low, it's not specialized and integrated at the same time. Inferential power, those cases in which without a theory you are lost, now you can use the theory. We heard from Joseph the reference to inference to the best explanation. So if you have a good theory that based on a few Parsimonious principles explains lots of data, makes predictions that are validated, then it becomes your inference to the best explanation, and you can begin to use it for these difficult cases. And you can look at things that systems condense down. You can have very simple systems that are conscious, although minimally so. You can have inactive systems that are conscious, but inactivated they wouldn't. You can have complicated systems that are unconscious. You can have functionally equivalent systems that behave like us, which have not an iota of consciousness. And particularly, if you go now to supercomputers, digital computers, or even simulations of my brain, or anybody's brain, the theory says in non-certain terms that there is no consciousness there, even though they might be functionally equivalent. Thank you very much.